Hi there. Continuing on with our story of functions, we're going to have a wee look at not just evaluating what a function is, but evaluating what a value of x is when we know what an actual function is equal to. So in previous examples, what we had was a value of x being substituted into a function to give a corresponding value of y, which is what f of x is equal to. This time, the question is saying, what is the value of x when the function itself is equal to 2? So it's not when an x value is equal to 2, it's when the function itself is equal to 2. So we're really doing this from the opposite process now. So if f of x is equal to 4x, and f of x, in example A here, if f of x is equal to 2, then logically it must follow that 4x is also equal to 2. So think about that again. If f of x, if this function is equal to 4x, and that same function is also equal to 2, then it has to follow that 4x is equal to 2. From there, we then build up an equation. If we have 4x is equal to 2, x is equal to 2 divided by 4, which is a half. This is really a bit of logic that you should really consider here. Let me give you a simplified example, and this is purely off the top of my head here. Let's say that we have an elephant, and the elephant, that's what represents f of x. The elephant is our function. So let's say that the elephant is equals a weight of 4 tons. And that same elephant is also equal to 2 years old. It therefore follows that a 2-year-old elephant is going to equal 4 tons. So if the elephant is 4 tons in weight, and if the elephant is also 2 years old, and we're still talking about that same elephant, then you would expect that when the elephant gets to 2 years old, it's going to weigh 4 tons. So just a little bit of logic just to digest for you there. Let's look at example B then. Okay, so I've got the same function, f of x is equal to 4x, and we also have that f of x is equal to negative 10. So let's go ahead and take this with that same logic. It must follow that 4x is equal to negative 10. Divide both sides by 4, so we get x is equal to negative 2.5 when you go ahead and solve the equation. Remember, these are always self-checking, so you can always go back and take your x value and substitute it into your original function, and you'll get your original answer. So if I take minus 2.5 and substitute it back in for x, 4 times minus 2.5 does give me minus 10. The last example here, we have f of x is equal to 34. So if f of x is equal to 4x and f of x is equal to 34, it must follow that 4x is equal to 34. So then just solve that equation, so we get x is equal to 8.5. Okay. Let's take a look at the next example. Okay, so we're going to start to bring it all together here. Example 4. starts off with a question. So we've got a function. F of x is equal to 8 over 1 minus x. First question here is saying, why can x not be equal to 1? So if I was to substitute 1 into this function, why can that not happen? Why can x not be equal to 1? Well, if I was to do that, if I was to work out f of 1 and substitute 1 into the function, then we end up getting 8 over 0. So if, for example, I worked out f of 1 and I worked out 8 over 1 minus 1, I would get 8 over 0, which is undefined. Okay, we can't define a number when we divide it by 0 because we cannot divide by 0. It's impossible. So when we have certain functions, and this doesn't apply to all functions, but it applies to certain ones. Again, you will learn this a bit more in higher maths. There are some restrictions to the domain of the functions. There's restrictions to the numbers that we can substitute into the functions because they just don't seem to work out. Again, don't bog yourself down on that too much just now. So, example B, it says calculate f of negative 1. So that's just asking us to take the value of negative 1 and substitute it into the function wherever we see an x. So I can say that f of negative 1 is going to be 8 over 1 minus 1, which is going to be 8 over 1 minus 1 is 1 plus 1, which is 2, which gives us 4. In that same way, we have f of a half. So we're going to take a half and substitute it into x this time. So that's going to give me f of a half is equal to 8 over 1 minus a half. So 1 minus a half just gives me a half, so it's going to be 8 over a half, or 8 divided by a half. Now you could work this out using a calculator, that's not a problem, but you could also work this out without a calculator, because really all we're doing here is just working out a division of fractions. Remember, a fraction is just a division, so 8 over a half just means 8 divided by a half. And we should all know by now that when we divide a fraction, we turn it upside down and multiply. So 8 multiplied by 2, which gives us 16. Example part 3, f of a negative a half. So take negative a half and put it in, which is going to be 8 over 1 minus a half. So that's going to be 8 over 1 minus a half is 1 plus a half, which is 3 halves. So again, you could just plug that into your calculator. You could even just plug it into the calculator as we see it on the first line there, and you would get the answer. But at your stage, you should be able to evaluate this in terms of the numeracy that's involved here. So 8 divided by 3 halves is the exact same as saying 8 divided by 3 over 2. Remember, dividing fractions, we do keep, change, flip. So it'll be 8 multiplied by 2 over 3, which gives us 16 thirds. Let's just leave it as that. Okay, we could write it as 5 1/3, but as long as our fraction is simplified, there is no need to change a top-heavy fraction into a mixed fraction or as a decimal. Part C. This time, again, read the language of the question. Look at the difference between part C and the examples in part B. This is not asking me to work out f of a number. This is saying that the function itself is equal to 2. So what we have here is our function, f of x is equal to 8 over 1 minus x. That function is going to be equal to 2. So I'm going to make it say 8 over 1 minus x is equal to 2. And really we'd have a little bit of an algebraic fractional equation here to solve. So what I would do here is I would multiply everything by 1 minus x to get rid of the fraction. Remember, I've got one fraction here, 2 is the same as 2 over 1. If I multiply everything by 1 minus x, that gets rid of the fraction that's on the left hand side, but what we do to one side we must and always do to the other side. So that's going to give me 8 is equal to 2 brackets 1 minus x. If you have another way of working that out and making it work out to get the right answer, you keep doing that. So let's go ahead and expand the brackets. So we get 8 is equal to 2 minus 2x. So swap it round. So we get 8 minus 2 is equal to minus 2x. So minus 2x is equal to 6. Divide both sides by negative 2. So we get x is equal to negative 3. So the actual logic is quite simple. What to do whenever you have a function. If it's f of a number or g of a number, then you just substitute it in wherever you see an x. If you have the function equaling a number, make the basic function equal to that number and then go ahead and solve. What I think might be slightly trickier for you is the numeracy skills at level 5 required here. Really, in part 2 and part 3, there's nothing here that you should not be able to do. So if you don't understand what I've said here in terms of substituting in fractions and working with fractions, then that's something that you need to go back and get some more practice on. And if you need more work on it, then please let me know and I will provide you with that and extra help to help you get up to speed with it. But it's essential that you are able to work with fractions, because the more we go on into mathematics for the rest of National 5, into higher and beyond, the more fractions are going to have to be involved, because you won't always have a calculator there.